Close your eyes for a moment and let your mind drift back, not just years, but billions of years. Imagine a time when our universe was barely a toddler, less than 2 billion years old, still finding its form after the immense burst of the Big Bang. In that cosmic infancy, one would expect to find the building blocks of galaxies, certainly, but perhaps not fully formed, stately structures. Yet, every so often, our telescopes peer into that distant past and reveal something that gracefully, yet profoundly, challenges our conventional understanding of how the cosmos came to be. Today, we delve into the story of one such celestial enigma, a galaxy so remarkably ahead of its time that it seems to have skipped billions of years of evolution. Its name, a mouthful for sure, is ALMA J081740.86 plus 135138.2, but for simplicity, let's just call it the early bloomer. The early bloomer is located more than 12 billion light-years away. To grasp that distance, remember that the light we are seeing from it today embarked on its journey when the universe was only about a tenth of its current age. This means we are observing it as it was in those incredibly nascent days, less than 2 billion years after the Big Bang. Now, picture what astronomers typically expect to see when they look at galaxies from that era. At such a tender age, conventional cosmological models suggest that about 90% of galaxies, well, frankly, they were train wrecks. Imagine vast, chaotic clumps of gas and dust still struggling to find any semblance of order. They were like cosmic toddlers, flailing about, assembling themselves in a very haphazard, disorganized manner. Their shapes were irregular, their motions turbulent, and their masses, while growing, were still relatively modest. This chaotic period is a crucial, if messy, part of galactic development. It's during these tumultuous times that gas and dust eventually begin to settle, cool, and coalesce slowly, over billions of years, into the elegant, well-ordered spiral and elliptical galaxies we see in the mature universe today. It's a process that requires immense time, patience from the universe, and a certain degree of gravitational calm to achieve. But our dear ALMA J081740.86 plus 135138.2, our early bloomer, defies this expectation entirely. Instead of a chaotic mess, it sported a beautifully formed rotating disk. More astonishingly, it matched our very own Milky Way galaxy in size, spanning a magnificent 100,000 light-years across. And as if that weren't enough, it was incredibly massive for its age, weighing in at an impressive 70 to 80 billion solar masses. 70 to 80 billion times the mass of our Sun, all neatly packed into a finely tuned, rotating disk, at a time when most of its galactic peers were still just disorganized blobs. It was a beefy, well-structured antique, faintly shining across billions of light-years, showing off a level of maturity that simply shouldn't have been possible. This discrepancy presents a profound puzzle. Typically, it takes billions of years for galaxies to whip themselves up, then gradually calm down, allowing the gas within them to cool and coalesce into those familiar, majestic Milky Way-like structures we see in the mature universe today. It's a slow, painstaking process of gravitational attraction, collisions, mergers, and the settling of matter. So how could a galaxy achieve such a state of advanced evolution in what was, cosmically speaking, the blink of an eye? How could it skip ahead in the universal timeline? This is where the mysteries of the universe truly deepen and invite new theories. One compelling hypothesis suggests a fascinating shortcut, a kind of cosmic superhighway that bypasses the usual long wait times. Imagine vast, invisible filaments of dark matter. Dark matter, though we can't see it, exerts gravitational influence and forms a cosmic web, guiding the flow of ordinary matter. The idea is that in certain regions of the early universe, cold gas didn't have to wait for slow, conventional processes to gather. Instead, it flowed rapidly and efficiently along these dark matter filaments, as if traveling on an express lane through the cosmos. This accelerated delivery system of raw material could have allowed galaxies like ALM J081740.86 plus 135138.2 to accumulate vast amounts of gas and dust at an incredibly rapid pace. With such abundant and swiftly delivered resources, these premature, yet beautifully spiraling galaxies could form much faster than traditional models predict, essentially fast-forwarding their evolution by billions of years. This particular galaxy, our early bloomer, stands as a testament to the universe's boundless ingenuity and its capacity to surprise us. It's a gentle reminder that our cosmic journey of understanding is far from over. Each time we push the boundaries of observation, we uncover new questions, new pathways, and new possibilities that challenge our established frameworks. The universe, in its quiet, unassuming way, continues to teach us humility and wonder, showing us that its story is far more intricate and dynamic than we could ever fully grasp. Perhaps the next time you look up at the night sky, you might consider the vast, unseen network of dark matter, silently shaping the destiny of galaxies, guiding the very evolution of our universe, and wonder what other cosmic puzzles await our discovery just beyond the reach of our current understanding. Thank you for joining me on this journey through the cosmos. If this story sparked your imagination and left you pondering the universe's many secrets, please consider subscribing or sharing your thoughts in the comments below. Until next time, keep looking up.